Number 54, based on the data and tables above, which of the following statements provides the best prediction for the boiling point? Once again, I've been reiterating this multiple times, but whenever you hear the word boiling point, you're supposed to think what? Intermolecular forces, right? Because stronger intermolecular forces means you have higher boiling points, right? It's harder to separate those molecules by letting them overcome the intermolecular forces. So, we're trying to figure out the boiling point of this sodium chloride. I guess the best comparison we can make it is with this sodium fluoride over here. Well, the sodium and sodium is literally the same in both, so you really don't have anything to worry about for that one. The only difference is, well, one is fluorine, so fluorine's actually right there, and the other one is chlorine, so chlorine's right there. Well, what's the difference? Well, the ionic radius is different, right? And if you guys think about, once again, let's think about the whole idea of boiling point. Well, boiling point is basically due to the intermolecular forces. And intermolecular forces have to do with two different factors that play a major role in terms of how strong the attractive forces are. And that has to do with what? The Coulomb's law, right? The amount of charges and the distance between the cation and the anion is basically what matters the most. Well, the amount of charges, well, chlorine's got -1, fluorine's got -1, so they both have -1 charge. So we can't really talk anything about the magnitude of the charges. It's the same for both. The only difference is the ionic radius. Well, think of it this way. Would the attraction be stronger if they are closer or longer or farther apart? Definitely when they're closer, right? So probably it is going to be the case that the one with smaller ionic radius is going to be more closely attracted to that sodium ion, sodium cation. So this is probably going to be the stronger version, the sodium fluoride, that's going to be stronger than the sodium chloride. So long story short, sodium chloride should be a little bit weaker than the sodium fluoride in terms of the intermolecular forces, and therefore the boiling point of sodium chloride better also be lower than sodium fluoride. So let's take a look at the answer choices. A, sodium chloride will have a lower boiling point than sodium fluoride. Absolutely. Because the Coulombic attraction, that's literally what I say, Coulomb's law, right? Coulombic attractions are weaker in sodium chloride than sodium fluoride. That's literally what I said. That's why answer choice A makes the perfect answer. Remember, if anybody needs any review, the Coulomb's law basically states that force due to charge is equal to the constant K times Q1 times Q2. Those are the amount of charges for both of the particles, all over R squared, where R represents the distance between the two ions, right? So, choice B, sodium chloride will have a boiling point between that of sodium fluoride and magnesium oxide. So like in between these two, hell no, we just talked about it's even lower than the sodium fluoride. So that's a no-no. Sodium chloride will have a higher boiling point than magnesium oxide. Absolutely makes zero sense. Magnesium oxide is like 3,600 and we're not even somewhere close to 1,700. So no. D, sodium chloride will have a higher boiling point than magnesium oxide. That already itself is so wrong. That's why answer choice A has to be the correct answer.